All right, today's notes are on 10-2, measure angles and arcs, and we'll dive right in. Oops. And so the first thing we have to understand today is the concept of a central angle. A central angle is an angle where the vertex is at the center. And so here angle ABC is a central angle because the vertex is at the center. And so for all the angles you're going to deal with in circles, it always is a matter of where is that vertex. That vertex can either be inside the circle, on the circle, or outside the circle. And so in this case, the vertex is at the center of the circle. Central angles will always have 360 degrees. All right. And so if you combine here, angle 1 is a central angle 2 is a central angle, and angle 3 is a central angle. Right? They will always have 3 because there's 360 degrees in a circle. Right, which is what this 1 degree is, just 1/360th of a circle. Right? And then what we're going to come to learn is the central angles tie very much together with their arcs. They intercept. Right? And so that's the next thing we're talking about. So this central angle, all right, intercepts 2 arcs. This angle here obviously intercepts this arc. Right? But this angle also, if you look at it kind of, and it's weird to look at it, kind of intercepts this arc. Right? So it basically splits up into 2 arcs. Now it can have a whole bunch of central angles, so you have a whole bunch of arcs as well. And so just know that the central angle ties directly with the arc in most cases. I mean, it ties directly with the arc in every case, but when it's less than 180, it makes more sense here. And so let's talk about that. That's called a minor arc. Right? And so notice these 3 circles, they broke up, but now we're talking just from P to R. So if we're talking just from P to R, we're just talking about this arc. And so that means that we're just talking about this angle. Right? And so the angle X there is going to be less than 180. It's less than half the circle, so it's less than 180. And so that's a minor arc. And so minor arcs I would usually name using just 2 letters. So arc like PR with that little swoop on it. Now I could put another point here and name it using 3 letters, but I don't have to. So minor arcs, usually 2 letters, can be more than 2 letters. A major arc. And so major means it's bigger than 180. And so this one's talking about PSR. So from P all the way through S to R. Right? The angle intercepts is this weird combination of things here. So it's bigger than 180 because it's this 180 plus whatever this is. Right? But that's a major arc. So when it's bigger than 180, I have to name it using at least 3 letters. So both of these arcs start at P and go to R. But when I say PSR, that means it starts at P and it goes to R through S. If I just say PR, it's going to go the quickest way possible. So it can go this way or this way. Well, the quickest way possible would be this way. So you're always going to use 3 letters when you're naming a major arc. Semicircle is when it's exactly 180. All right, you can kind of say you could go either way with the letters. It's most commonly accepted that you would still use the 3 letters. And so arc from R to T through S. R to T through S, that would be one. Or you can go from R to T through P, so R, P, T. Those would both be semicircles. They're both half the circle, so they're exactly 180. I know it's half the circle because RT is a diameter. Right? And so R starts at the diameter, T ends the diameter, so it's exactly half the circle. All these questions are about combining the fact that the central angle links with the arc. And so X is right here. I know that the whole thing has 360 degrees. So I'm first going to do all of them added up. 90 plus 40 plus 85, right, equals 215. And so I have 360 total all right? But 215 already there. And so 360 minus 215. I take a calculator, I type that in, and I get 145, and so x equals 145 degrees. You don't need to put a degree sign. AC is the diameter. Drag each description of each one. So DAB. So DAB is the first one they want to talk about. So DAB right here. DAB, D to B through A. D to B through A. Looks very much like it's more than 180. And so that is a major arc. How many degrees is it? Well, if this line right here is 180 and that part's right there is 47, I want to do 180 minus 47. And this over here is 133. And so this right here is 90. And so this angle is, those two combined, 223 degrees. The next one here is DC. DC is this arc right there, which intercepts this angle. The angle on the inside there would be 90 degrees. If this one half's 90, the other half's 90. And so that is a minor arc. It's less than 180. And it's actually exactly 90 degrees. And then ABC. How many degrees is it going to be from A to C? A to C. How many degrees is that going to be? Right. I know that it goes exactly half the circle, and that word for that is semicircle. And how many degrees is that? 180 degrees is correct. So it wants me to find DE. So first, where is DE? D is right here. E is right here. So it wants me to find the measure of that arc. That arc hits this angle, and that angle is not 12 degrees. It would be so awesome because if it was 12 degrees, I'd be done. It says 12%. So I know it's at 12%. 12% of what? 12% of the circle. The circle's got how many degrees in it? So 12% of 360. So I got to change to 12 to a decimal. Of becomes multiply by 360. So you change the degree to a decimal. Of becomes multiply. And I get my answer here is the measure of arc DE is 43.2 degrees. Still, again, combining the measurements of arcs and semicircles, or central angles and arcs go together. And so WY, well, first let's highlight, what the heck are we talking about? Arc from W to Y. From W to Y, the quickest way there, because it's two letters, so the quickest way there is this way. And so the measurement of arc, WY, is going to be the 90, because this part right here is 90, and this part right here is 62. And so the measurement of the whole arc is 152. Last thing we're going to deal with, and we're not going to do a whole bunch of problems like this, but it's arc length. And so this is what I need to know, all right? Arc length is the degree, the measure. I'm going to put M for measure. All right, the measure of the angle or the arc, because remember, arcs and central angles the same, divided by 360 times the circumference. And so I'm going to do 2 pi r. You could also use pi times diameter there. Right? So it's the measurement. That's what you need to have in your notes. The measurement of the arc, which is also the same as the central angle. All right, divided by 360 times 2 pi r. And so we got all kinds of things here. I kind of want this as a fill in the blank. I know it's 360 there, and it's 2 pi r there. And so the length is the measurement of the angle, right? And so it says find the length to the nearest hundredth. And I think here what we're leaving out is they want us to find the length of AB. And so we're going to find the length of AB, arc AB. And so A to B right there. And so I plug things in. That's 80 degrees out of 360 times 2 pi and the radius. Now the whole thing here is 14. And so the radius is only 7. Right? And so I do 80 divided by 360 in a calculator times 2 times 7 times pi. And I get my answer is 9.77. And so you just let the calculator do the heavy lifting. There's no reason for you to memorize that formula, but you should have that formula down, or equation for arc length down in your notes. And that is where I will wrap up today's video. Have a great day.